Thank you very much, ladies and gentlemen. My name is Mr. Chika. I'm a lecturer in a program called Radiation and Health Physics at the University of Botswana. I'm here today to give you an overview of what this program is all about. And I am the one that you are seeing on the right hand side of the slide that you are looking at. There are 8 of us teaching in this program, and I'm just one of those 8. Now, I'm going to start first by giving you an overview of what this program is all about. And we are going to start first by looking at when and why this program was formed, what are the core structure of this program, what are the main instruments that we use in our daily teaching. I will also look at where our graduates are, what they are doing in this university. We will look at the challenges that we are experiencing. We will look at the current program review that is ongoing and the way forward. Why was this program formed? Radiation and Health Physics program was formed in 2011, and this was a result of a request from the Department of Radiation Protection then to mount a program that would assist in producing the necessary human resources with the appropriate technical expertise to meet the challenges of the use of ionizing radiation then. This was as a result of Botswana having joined the International Atomic Energy Agency in 2002. So we were expected to produce sufficient manpower that will then be used to staff the regulatory authority itself because RPI was still new by then, and have enough human resources to be available that can be employed by the industry to assist with the radiation protection matters. This is why this program was formulated. The structure of our program. Radiation and Health Physics is a hybrid program in that part of it have to do with the medical fraternity, and then the other part of it have to deal with the environmental physics aspect of it. Now, why was this important? This was important because when the program was formulated, the intention was that we needed a graduate that understands fully the use of ionizing radiation in hospitals. We know that hospitals are the main users of ionizing radiation in this country. Hospitals use ionizing radiation for diagnosis of diseases and for therapeutic purposes. So we needed a graduate that will full understand how ionizing radiation is being used in this industry. The other part of the program has to deal with the use of ionizing industry in institutions like BUST, who use ionizing radiation for scanning cargo, institutions like airports that uses ionizing radiation for security scanning. We are looking at institutions here like universities that conduct research on naturally occurring radioactive material. So we needed to have part of this program covering this other area of ionizing radiation. And the two of them combined then created a program that we call radiation and health physics. Now, some of the main courses that we are covering in our program, courses that have to do with medical applications. We have a radiation biology course that deals with the effects of ionizing radiation on the body. We have radiation therapy that deals with the use of radiation to treat cancer. We have radiography that deals with diagnosis of diseases using X-rays. We have a radiology that deals with interpretation of images. We have medical imaging physics that deals with the use of a non-ionizing radiation for medical imaging. We have human anatomy and physiology, and then we have the clinical internships that we send our students to hospitals to go and have hands-on experience. We have other radiation physics courses that mostly have to do with norms. We have radiation physics 1 and 2 that deals with where the ionizing radiation comes from and how it interacts with matter. We have environmental physics that deals with naturally occurring radioactive material. We have instrumentation that deals with detectors. We have nuclear rules and regulations. We have applied nuclear physics. We have radiation protection and dosimetry. And we have applied radiation safety techniques. Now, other courses that are included in these programs are done in other departments like School of Allied Health Sciences to augment what we are doing in physics department. The core instruments that we are using in our day-to-day teaching would include instruments like a gamma spectrometer, which we have, but currently it requires a repair. We have the ED2000, which is an X-ray fluorescence system. It requires a repair also. We have the Alpha Gade, which is in a good condition, is working. We have the X-ray diffraction system, which is housed at geology department. It also requires some repair. We have a new sodium iodide gamma spectrometry system. It's working and it's in good condition. And we have several Monte Carlo simulation softwares that we have in our labs, and they are also running well. Now, where are our graduates and what are they doing? Since its inception in 2011, the program has produced 63 graduates, of which 7 have been employed by RPI, the regulatory authority. 1 is employed by UB as a temporary full-time demonstrator, and 1 is employed by the Ministry of Basic Education as a teacher. We have 4 students of ours who are doing PhD in BUST. We have 5 that are also currently doing their MSc, and 2 have already completed. They are busy marketing. We have 2 students that are doing MSc Medical Physics in South Africa. We have 1 doing a PhD. We have 2 that are doing MSc in Medical Physics in India, and they will be graduating in January. We have 2 that are leaving this month of October. They are also going to India to do their MSc Medical Physics this month. We have 1 of our students who is employed at the Seiki-Tumile Referral Hospital, and he is working as an assistant medical physicist. Current review and way forward. Our program is undergoing a curriculum review. University of Botswana employed an expert from South Africa to review our program, recommendations of which we have infused into our draft reviewed curriculum in order to strengthen our program. We have, as a group, also decided to include 2 physics general courses that will allow our graduates to be able to teach secondary school physics. We know our country is having a challenge with physics teachers, and the suggestion in the group is a way of trying to assist our country move forward. We have decided we will include in our program 2 courses in physics general that will allow our students to go into the community and start teaching our students physics. When this draft review has been completed, we will send it to the stakeholders to look at it, have their own input with an intention that it should be implemented in the next academic year. This, I believe, is a fair summary of our program. And if participants have questions, me and my colleagues are available to address those questions. Thank you very much for your attention.